Welcome and hello. This is a video exercise in MODSIM. And in this exercise, we're going to be talking about least cost routing in network flows. So what we're going to be doing here is building and running a simple network model with various link capacities and costs and analyze the increasing cost to route additional capacity through the network. All right, so here is my MODSIM. I've got the interface up and ready to go. This is an exercise, so we're going to build everything from scratch here. Next, I'm going to bring up a model schematic to show what I plan to draw out in my network. Here it is. I have a network where flow enters through the top to this node right here. After that, the flow has to split and either go left or right. From these left and right nodes, they can either go to each other or they can go down to this bottom node, and then finally the flow leaves through this bottom node right here. Okay, so let's go ahead and add some nomenclature or some node labeling. Here we have the node N1, N2, N3, and N4. Keep in mind N2 and N3 can flow back and forth to each other. So it's you may call it bidirectional. All the other links right here are unidirectional. In the next slide here, what I'm going to do is identify the minimum, maximum, and cost of each of the links. So what you see here through this first link here and also the last link, it's going to have a minimum of 0. Well, that's going to be true for all the links. This one will have a maximum of 100 and a cost of 0. So here's the link notation label up here. It says min, max, and then the C is for cost. I guess I could have wrote that out, but C is for cost. So min, max, and cost. All the links are going to have a minimum of 0 and a non-negative cost. Here it is. So I've labeled out N1, N2 link, for instance, has a minimum of 0, a maximum flow capacity of 10, and then a cost of 5. Whereas N1 to N2 has a cost of 8, minimum of 0, and a maximum of 50. I also wanted to just point out that the min-max cost for N2 to N3 and N3 to N2 are labeled up over here just because there wasn't any space here in the diagram. So these are the link parameters that we're going to use when we build our network in MODSIM. So let's go ahead and get started. I'm going to pull that off to the side here and start by adding in my nodes. So I'm just going to select non-storage node. This is going to be my N1, my N2, N3, N4, and then I need a sink here at the bottom, so we'll just add a sink. Okay, let me go ahead and label these. So N1, this is going to be N3 over here. This one is N2. This guy is N4, and then I'll just leave the sink labeled as sink. Okay, let's go ahead and connect these nodes now. So N1, N3, here's N1, N2, N2, N3. What I'm going to do is just bend this one a little bit. Okay, so N3 back to, N3 back to N2. Let me also bend that. And then we have, let me move that label, N2 to N4, N3 to N4, and N4 to the sink. Okay, looks good. I'm going to move all this up just a touch. And let me save the network before I get too far. I'm going to call this exercise 7 and save. Okay. All right, let's go ahead and update the link properties. So N1, N2, I'm going to go right click and properties. Now what we need to set is the cost. And what I said for that particular link was 5. And then the maximum is not going to be 30 million. It's going to be just 10. And that's a constant maximum. I'll click apply and then OK. So let's continue that process for the other 5 links here. Actually, there's also a link down here, but I don't need to make any changes because, well, I guess I could say it's 100. It is 100, but that's inconsequential. There's 0 cost. It's the only way for the flow to leave the network. Okay. From N1 to N3, I'm going to go right click, properties. Now the cost through this link is 8, and then the maximum is 50. So there's that. Apply. Okay. Next, let's do N2 to N3. So right click, properties. The cost there is 2. The maximum is 18. So there's 18. Apply. Okay. N3 to N2. Right click. Properties. That has a cost of 0, but a max of 12. Apply and OK. 2 more to go. N2 to N4. We can also open the properties box by clicking on that right there. This has a cost of 7, a maximum of 30 units. These are going to be acre feet per month is the units that we're going to be dealing with here. And then N3 to N4 is the last one. That has a cost of 3 and a maximum of 15. I'll click apply and then click OK. Next, what I want to do is we'll save it and then network settings. So MODSIM menu, network settings. What I'm going to do here is let's increase the precision to 2 decimal places at least. I'm trying to get in the habit of doing that, even though I don't think that's necessary for this particular exercise. And then something else I want to do is set the time. So if I click on the time step, I want to use 24 time periods in this simulation. So I'll just stick with month for the time step. So 24 months in that case would be 2 years. I'm going to increase the 1981 to 1982. And then I need to extend the simulation date. This was the data end date. The simulation end date should be at the end of 1981 or the very beginning of 1982. Okay, so that looks good there. I'm going to click apply and okay. The last thing I need to do for this model before running it is to actually add the flow. These are all non-storage nodes. There's no reservoir or anything in this model. And the flow leaving N1 has to go either to N2 or N3. So I'm just going to add inflow to this N1 non-storage node. And I'm going to just ramp it up 1 unit per time period. So let's check out what we got here. I've got the node selected this time. And the units for the inflow is going to be in acre feet per month. So that's fine. I'm going to click on varies by year. Okay. And then on my clipboard, I just off camera copied some data. So I'm going to right click and then paste time series. And here we have each month, the flow rate increases by 1 acre-foot per month. So we have January is 1, February is 2, all the way down to what is 24 on December of the second year. We can click on the plot and just see what that looks like for ourselves. This is the line version. If I click on the bar version, boom, you see the stair step pattern as it increases 1 acre-foot per month. So apply and okay. That looks good. Now, before we run the model, I'm going to bring up the diagram to screen once again so we can maybe ballpark or visualize what we think is going to happen. Because in the very first month, we know there's one flow of water, 1 acre-foot entering this node N1. That's a boundary condition. But then what's the cheapest way for that water to get to node N4? And it really has four routes, right? It can go left, it can go right, it can go S, or it can go backwards S. That's just what I'm calling it. So once it gets to node N1, it has to go either left or right, right? Left would cost 5, and then right would cost 8. So here's the 5 through N to N2, and then over here, the 8, that's the cost to get to N3. Now to get from N2 to N4, that'd be an additional cost of 7 for a total of 12. However, if you're at N2 and you want to go from N2 to N3, that would be a cost of 2 plus and a cost of 3 more to get from N3 to N4. So the very first unit of flow is going to go N1 to N2 for a cost of 5, N2 to N3 for a cost of 2, and then N3 to N4 for a cost of 3 more for a total cost of 10. And I actually propose that the flow is going to take that exact route until one of these links hits a max capacity. So the max capacity from N1 to N2 is 10, from N2 to N3, that is 18, and then from N3 to N4 is 15. So for the first 10 months, the flow is going to increase and only go in this particular direction right here. And I think it's safe to say that link N1, N2, and link N3, N4 will be fully flowing for the rest of the simulation. I'm not sure if that's really true between link N2 and N3 though, because after N1, N2 is fully flowing, then that means the remaining 14 acre-feet of water needs to go through from N1 to N3. That's non-negotiable. That's a hard constraint, and that's going to be a cost of 8. So what's the cheapest way to get from N3 to N4? Well, it's probably right here. It would cost just 3 to get from N3 to N4. The other option is go from N3 to N2. That's a cost of 0. And however, the cost from N2 to N4 is 7. So I think for the next 5 acre-feet, we're going to have 5 going through here and then an additional 5 going through here, at which point link N3, N4 is going to hit its maximum, and then something else is going to happen. And that's why we have computers, so I don't have to try to figure this out by myself. All right, who's ready to run the model? I am. I'm going to save it first and then click on the Run MODSIM button and then click OK. Okay, so that ran. Now let's go ahead and see what we're looking at here. I'm going to toggle on the graphing mode. So go up to the MODSIM menu, click on graphing. This just makes it easier to select the data. Let's talk about N1, N2 first. Okay, very cool. This is what I expected. We have the flow increasing up for the first 10 units until it hits its capacity, the first 10 months here, up to 10 acre-feet per month. And then after that, it just flatlines and stays constant at 10 acre-feet per month. Okay, let's check out N2 to N3. So I think that's going to also go from 0 up to 10. And then after that, I'm not quite sure. So let's just check it out. Graph. Okay, interesting. So we still have N1, N2, but N2, N3 goes up. It stays at 10 for, I believe, 5 months, while this is filling up from 10 to 15, after which point it goes back down to 0. So that means this link right here, N3, N4, will go from 0 up to 15 acre-feet per month for the first 15 months, and then it should just stay at 15. Let's click that button, and then boom, yep, here it is, that dark orange line. This is N3, N4, which is this link right here. All right, so we could do that for all the links. What I'm going to do is actually close this, unselect, and then select all the links and get all the data. And my end goal here is to analyze the increasing costs as the flow increases. So with the graphing mode still enabled, we'll just go ahead and click N1, N2. Then I'm going to minimize this box so I don't have to keep seeing it every time. Next up is N1, N3. Then we have N2, N3, N3, N2, N2, N4, and then N3, N4. Did I get that one? Okay. Let's see if I got them all. There should be 6 series of data here. 1, 2, 3, 4, 5, 6. Okay, that makes sense. And then here's the plot right here. Now what I'm going to do next is actually plot out the data and the flows through each of these links. What I have here is the inflow. It goes from 1 up to 24. And then I have the cost of flow through each of the 6 different links, 5, 8, 2, 0, 7, and 3. So I'm going to just paste in what is the flow, and then I'm calculating the total cost right here, which is the sum product of the cost and the flows for that particular month, which is increasing from 1 to 24. So for the very first month, we know that the first acre foot of flow went through N1, N2, and then it went through N2, N3, and then it went from N3 to N4. Boom. So this sum product right here gives me a cost of 10. We already talked about that. That's a little bit trivial at this point, but once we get later into the simulation, the flows start increasing, things can get a little bit more complicated. So this is the first month, but we have 23 more months to go. Thankfully, MODSIM has a very easy export function. Let me show you that. I'm going to start at the top with N1, N2. What you're going to want to do is click on this data tab, click the plus to expand, and then click on the series of data you want to see the data for. N1, N2 is this first one right here. Here is the flow. It goes from 1 up to 10, and then it stays at 10. And you just want to right click on this column header, copy column. Let's go back to Excel here. And then I should be able to just paste the values, and then boom, here are the values. And then here are the costs associated with flow through that link N1, N2. Okay, so I need to perform that task 5 more times. So hang with me. I'm going to minimize that. Next, click on, what is this, N1, N3. Here's the flow data. Copy the column, and then right click and paste. Okay, back to MODSIM. We have N2, N3. This is the one that actually goes up to 10 and then back down to 1, copy column, and right here is paste. Okay, N3, N2, that's next. Let's open that one up. Boom. Okay. All right, so there's no flow through N3, N2. I tried to incentivize flow by making the cost 0, but didn't work. Let's copy the data and paste it in anyway. All right, 2 more, N2, N4. I'm going to collapse that. N2, N4. Here's the flow. It increases towards the very end. That's one of the more expensive links, I believe. So copy column. Okay, yeah, cost of 7. Then we'll paste. And one last one is N3, N4, which is right here. Here's the flow. It goes up to 15 and stays steady. Copy column. And then here in Excel, then paste. All right. So let's take a look at our numbers. As the inflow increases from 1 to 24 acre feet per month, we have costs starting at a slope of 10. So if I was to graph these values, actually, yeah, let's just graph them. I'm just going to do a simple XY scatter graph. So that is in insert, and then right here is the plot. Okay, so it's pretty much a linear plot. On the horizontal axis, that's the flow rate in acre foot per month. And then the vertical axis is the cost. And it's actually piecewise linear. I think there's actually 3 different slopes here. So let's look at the data. I'm going to delete the plot. Right, so the first 10, that's linear, and it's a constant increase of 10 cost. It's a constant increase of 10 units of cost per unit flow. And then after that, the slope increases to 11 right up here. And that's when N3, N4 hits capacity. So remember the capacity tops out in N1, N2, 10, and then in N3, N4 at 15. And then after that, it looks like we have a slope of 13 to the very end of the simulation. That's what I was going for in this lesson, where we could see how, because the LP solver in MODSIM seeks to minimize the cost, the flow through the network is trying to minimize its cost as it has to accommodate more and more flow. And that's what we're seeing in these numbers here as the direction and magnitude of flow changes, sometimes even decreases based on the network max capacity and cost through each link. That is my exercise in least cost routing and network flows. Just for fun, if you want to stick around, I am curious what this looks like when we simulate it, simply because a lot of my lessons in exercise don't even set the max capacity for these links, but this one does. And I can colorize the links while I step through the different time periods where we'll set red to be like the maximum. Let's see if I remember how to do this. Go up to MODSIM and then let's toggle off graphing mode and then MODSIM menu animated output. It's giving me this dialog box and I'm going to set the speed to faster. And then down here for the links, I'll check that on and then percent full and then click on set color range. Okay. And then how many classes? I'm not sure. I'll just say 10. And then blue basically means there's 0% capacity. Red means 100% capacity. So, based on what we know from this exercise, we should sort of know what to expect and when. So I'll click OK. And then I'm just going to click the start button right here. And then in this time step dialog box, you're going to see it count from 0 up to 23 for the 24 different time periods. And then the colors will change as well for the links. So I just click start. It's running now. Okay, this is another thing I forgot. It needs the Access database file. So I'm going to have to just rerun the simulation real quick. Okay. All right. So let me just put that on pause. I'll come back to that in a moment. We need to go up to MODSIM and then select on Output Control. Click on MDB Access and then click Apply in the bottom right and then click OK. All right, so I'm going to save that. I'm going to rerun the model. It's going to save the results as an Access database file, which apparently is required for me to animate the colors on each of the links. Okay, so let's try what we did again. MODSIM, animated output. Here's that dialog box. And then that looks good. We want to click on link, set color range. Oh, I need to click on the percent full. Okay, now set color range. There we go. And then for classes, I'm not really sure what to put. Let's just go with 10. So I guess 10% it'll be a different color. Remember, blue is going to be 0%. I believe red is 100%. Okay. And start. Okay. So it's going too slow. Let me hit stop and change it to faster and then resume. There we go. So we should see N1, N4 hit red first. Yes. And then N3, N4 hit red. And then I don't think any of the other links are max capacity. And that's the very end right there. Okay. So it stopped. It started over. I'm going to click start the simulation one more time. So start. I think N3, N4 gets a little bit closer. Yeah. So it hits the green, which is, I'm going to hit stop right here. So if I hit stop, I can also just toggle up to 21, 22, and 23, which is the last time period. We can see the date right here. This is the last month in the 2-year simulation duration. And then we can look at the capacities if we wanted. But it looks like the only links that got close to max capacity were here at N1, N2, N3, N4. And I assume that that 13 cost per additional acre foot per month cost could continue quite a ways, simply because all the other links in the network right here don't look anywhere close to near capacity. Otherwise, the color would probably be yellow or even orange. And then red, I believe, is 100% capacity. All right. All right. Well, that's it for this exercise.